Hey everyone, this is a video on section 3.4, and this will tie in the end of Unit 3, all about financial math. So, in 3.3, we talked about future value of an annuity, sinking funds, and now we're going to talk about present value of an annuity and amortization. Okay. So let's just think about this first question here, just to kind of thought provoke a bit. So let's say we had, how much should you deposit into an account paying 7% compounded semi-annually if you wanted to, let's say, withdraw $2,000 every month for the next 2 years? Okay. So let's say, for instance, you won the lottery, right? And how much of this winning should you put in the bank, let's say for your mom or your dad or your relative, that they can take out so much every month to pay all their bills? You can think of this as one scenario, okay? And this does happen often with other things as well, okay? You could try to think of this, let's say you want to spend so much money a month, let's say on coffee, donuts, pizza. How much should you take out every month or put in at the beginning, right? If you want to take out, let's say, $100 a month. So, one thing to note here is assume after the last payment, that $2,000, no money is left in the account. Okay. So it does go through some formulas here, and it's similar to the previous one. And you want to think, since we're kind of taking out money, you see that power is negative. So in the past, some students kind of thought about that, like if you're taking out money, then it's being reduced. So that negative exponent to make it smaller. So for this particular problem, you have 7% compounded semi-annually. Okay. And they rounded this. Okay. So how did they get that I? They just did, so this is 7% here. So this up here should actually be 6%. Okay. So typically whatever your percentage that you're compounding annually, monthly, semi-annually, that is your rate. And remember, your I is your R over how many times per year. And in this case, semi-annually would mean it would be 2. So if we do that 6%, right? And then they just plug everything in and they get that value of $970.87. Right? So one thing to note is this one example here could be a little confusing. So let's look at an example in the formula. Okay. So one thing on the MyLab, some of the things you'll find is their weight per period. Okay. And so forth. So one thing I do want to say is, how much should I deposit into the account now? Right? So you're looking for how much money should I put into the account now? So, obviously we're not going to put $900 in. So, and this problem, this here is confusing a little bit because it's kind of jumbling some stuff together. So let's just look at the first example and see what happens. So formula here. So you notice this looks very similar to the last one. Some things are moved around. Present value payment, you see it's 1 minus, parentheses, 1 plus I to negative n. Remember, I is your rate per period. So that's usually your rate divided by m. So remember, rate is typically in the previous one, it was semi-annually compounded at this percent. Okay. And the number of periods would be, typically your m times your t, right? How many years times how often per year does it happen? Right. So let's look at this first example. Let's say we want to, what is the present value of an annuity that pays $5,000 per month for 5 years if money is worth 6% compounded monthly? So what's going to happen is, at the end of each, this is compounded monthly. So at the end of each month, I'm going to take $500 out. Then the money that's left is going to gain some interest. And then the next month, I'm going to take $500 out. Then it's going to gain some interest. And then the next month, I'm going to take $500 out, and so forth. And this will happen for 5 whole years. And that last amount I get should be exactly 500. You might have a cent or two difference. Okay. So what I want to know is how much money should I just put in there now so this can happen, right? So you want to think. This says it's 6% compounded monthly, so that means our R is 6%. And then monthly means your M is 12, and 5 years means your T is 5. And your 500, this is how much you're going to get paid. This is your payment every month, right? So remember to use our formula that we saw on the previous page. Present value would be how much you need in the account now for this to happen. Okay. Like, I wish my grandma or grandpa did this, but unfortunately, some things can't happen that way, okay? So this is our formula. All right. So we're going to have to plug in things. So we don't know N, right? N is how many times do we compound? So remember, N is your M times your T. So in this problem, 12 times 5, so that's a 60. We know what our payment is. It's 500. What about I? I, remember, that is your rate divided by M. Okay. So then that would be 0.06 divided by 12, which is super small, 0.005. Okay. So we're just going to plug everything in. So your present value will be 500. Then put parentheses. 1 minus parentheses 1 plus 0.005 to the negative 60 over 0.005. So then you just need to use your calculator or Desmos. So you should come up with the present value should be $10,000 and $345.11. Okay, so I need to deposit that much money now if I want to plan to take out $500 every month for the next 5 years. And honestly, some people actually do plan this. As I said, they want to set money aside maybe for some additional income, right? And that can happen. You might get an extra raise. So let's say you want to take out so much money every month. Maybe you want to do some extracurricular activities, go on a trip. Here you go. So let's go over to Desmos real quick and let's key this in. So make sure we can get the 10,300. Hold on, let me make sure. I think this will be a little bit larger. I noticed on my calculator I put a 200 instead of a 500. So let me double check real quick what this would be on Desmos. So let's just check on Desmos what it would be. So let's go over to Desmos. Let's delete some of the things from the previous thing. So I have 500, parentheses, and then you can do divided by to get your top and your bottom, and then 1, and then minus, parentheses again, 1 plus 0.005, close parentheses, and then you want to do your AB, but then you have to do a negative power. So watch, if I just do minus 60, it works fine, okay? So just key it in as you see it. Then we're going to divide it by 0.005, and then close parentheses at the end. So we see we need 25,864. Okay. 25862. So that's how much money I need to deposit now. Okay. And you can also calculate like how much interest, right, is actually made. So if you think about it, just hypothetically, if you just do 500 times how many payments would you get? 60, right? So this is what you would put in now, and you're going to get money back, right? That's how much you would get back, 500 times 60. So if you multiply that in Desmos, that is actually 30,000. So if we do the difference in those two, if we do the 30,000 minus 25862.78, we're actually making $4,000 off of this, okay, because of the compounding. So don't think of this as you're storing money and you're going to slowly take from it, right? You're actually putting it into some account. It's going to gain interest, but then you're going to take money out the same amount every month. So you can practice on number one here, match problem one. This interest thing I just mentioned, that's just to kind of give you an idea, like, why would you do this? Why don't you just keep it in your bank account? Well, I made almost $5,000 by doing this, right? So, and I was able to use all that money, $500 every month. So we have a retirement one here. So this one is a little complicated, as in you'll see that it says you have somebody earning 6.25%. Okay. And compounded annually is structured so that the person will make equal annual deposits into the account. So I'm putting money in the same amount for 25 years, and then I'm going to withdraw 20 equal annual payments of $30,000 to arrive at a balance of 0. Okay, so it's asking you how much should you be deposited annually to accumulate enough money to provide. So this is sometimes a confusing question. Okay, so we see here this happens all the time, right? Like you're planning for your retirement, so every year you're working, how much money should you set aside for your retirement, right? And let's say you want to do the same amount. So that's this first part here. You're going to put your retirement into an account. And then when you retire, what's going to happen? Well, I want to take out X amount of money every year. Let's say for 20 years. Hopefully I live that long after I retire. That would be nice. Okay. So how much money do I need to be deposited annually to make enough money to provide these future payments? So in this first part, how much should I deposit every month while I'm working so I can actually take out $30,000 every year for 20 years? Okay. So you can see this as this first part is kind of a future value sort of problem. You're putting money into an account, and then this, you're taking money out, right? And this is kind of a present value problem. So first thing that would be useful is, well, I know for 25 years, I'm going to take out $30,000. Sorry, not 25 years. The last 20 years, I'm going to take out $30,000 every year. So from a present value perspective, we're going to use this formula here. What did I put PWT on? Okay. And since this is technically using the same account, right? So I'm putting money into an account that's going to accumulate, and then what happened? It's the same retirement account. So as I'm taking money out, it's the same account, but it's still going to have the same interest rate. So this first part, well, it's accumulating money, seen as a future value problem. And the second part, after you retire, is a present value problem. So we're going to handle the present value first to figure out what should the present value be. How much do I need to save up after working for 25 years to technically do this for 20 years, to take out all that money? So I need to get what is the present value. Let's say if I retire today and I've been working for 25 years, what should be in the account right now? Okay. So the payment, I'm going to get $30,000. One thing to note, compounded, this is your R. Annually means your M is 1. Okay. And in this one, your T would be 20 for the present value because you're going to withdraw that for 20 years. So one thing to note here for the present value part, your I would be the same as your R because it's being compounded annually. Okay. And then your N would be the same as your T because it's compounded annually. So you'll just use Desmos here to get your present value. So let's see what we arrive at when I use Desmos. So practice, see if you can compute the right result. So I will use my calculator. And let's see what we arrive at. So just be careful of how you enter things in. So I arrive at 339941 and 14 cents. So I'm just double checking to make sure. All right, and it seems okay. So let me just, I think, right, so there is a slight change. So always make sure I left out one of the points after the decimal. So that's why you always want to double and triple check these because there's a lot of numbers. And as you notice, even I forget them sometimes. Right? All part of learning. All right, so I think everything looks fine now. I'll do one more check and then we will continue. Okay, so it looks like this is the present value. So that's how much I need in my account. Okay, so then I need to figure out if I'm working for 25 years and this is how much I want at the end of the 25 years, then what should I be putting in my account every year for those 25 years I'm working, right? So now this present value is seen as a future value for the past, okay? So if you recall from 3.3, and I don't think you have a question like this in your homework, but I do feel this kind of brings the two kind of ideas together. So think, I'm trying to figure out what my payment is for the first 25 years working to arrive at an account that has $337,000 in it. So what should I pay? Because that would be future value. And then so pretty much some things will be the same. So we have our future value here. So that will be 337,221.62. And then my I is the same. It's the same account. And then 1 plus I is the value here. What about N? Well, this is for 25 years every year. So N is technically 25 here because I'm working for 25 years for the second part of the problem. And then don't forget, you're going to subtract 1 in your denominator. So let's see what we get when we do this with our calculator. You can also check with Desmos to make sure that you get the right result as well. So 337 to 1.62. Right? And then so I write about that every month I need to make, sorry, not every month, every year I need to deposit around $5,000.29. Okay, $5,933. So, and if you want to kind of compute the total interest, right? Remember, it's how much money did you actually put into the account, right? So remember, for 25 years, you're paying this for how many months? So you put in minus take out. So you put in the 5,933.29 how many times? 25 times. And then we're going to take away from that. Well, how much am I taking away every month when I retire? $30,000. So, I might have wrote that. Hold on. I was thinking of this backwards. So we'll see that. We'll just calculate these. So I didn't mean to put a minus there. 30,000. So the thing is, to calculate the interest is how much did you actually put into the account, right? And then how much are you taking out? And the difference between those two numbers will be the interest you earn. Okay. Usually in these, you're always going to be taking out more than you put in because what's happening? You're earning interest. Okay. So if you compute these two values here, the first one will be 148,332.25. The second one will be almost a little bit over $500,000. So you'll see that you didn't really contribute that much, right? But what happens? You can almost take out over $1 million. So the interest you earn would be the difference in these two. So take out minus put in, right? So that would be right. So quite a bit of money. That's how much interest you earned, okay? And that's why a lot of people do save for retirement, okay? That if you put in so much, if you're going to work for a company a long time, you want to make the most out of your money, and most of the financial advisors at a job will do that. So you can look at match problem 2. And that's why saving for your retirement is beneficial. Okay. So this one talks about amortization. Okay. So one thing to note is that there are a few things here. For instance, in this example, you borrow this much in exchange for a series of 48 payments with the amount of these payments to be computed, right? And it says you borrow this, right? This says 48 equal months. So in this case, N would be 48. This says it's 1% per month or 12% per compounded monthly. So if it says 1% per month, that is your I. Okay. Typically, we do the 12% compounded monthly or annually. But if it says like 5% per month or 5% per week or 5% per day, then that is actually I. If it doesn't use the word compounded whatever, okay? You see here, if I do the 0.12 divided by 12 because it's monthly, I do arrive at that 1%. So in some of the things, even on your project or your Unit 3 project, I might include both just to kind of give you a hint. Okay. Your present value is, right, 15, right? This is how much. Okay. And you want to know what the payment would be. Okay. So you want to confine the monthly payment so you can practice with that, with this $15,000 here. And this talks about if you want to do amortization of, right here. You'll see it's a little bit different from the formula that we have. So amortizing a debt. So this is when borrowing money and making payments on a loan. Okay, so not like a retirement account. Okay. So this is used heavily, like let's say your car loan, house loan, okay? And you'll just notice that, like from a retirement account, all that extra interest, right? Almost $500,000 of interest just from this. So just imagine if you bought a house and you have to do amortization, you can't pay it off completely. How much interest are you actually going to be paying? And usually it's substantial. So let's look at example 3 here. And I do want to say that some of the parts of the sections will do like a table for amortization. We are never going to do that. Don't confuse yourself. Okay, that is very complicated to do. Okay, before computers, that's what they did. So okay. So suppose you buy a television that's $1,400 and agree to pay it for 18 equal months. So you're purchasing a TV for this much. That is the present value. 18 equal months. So this is already your in because it says how many equal month payments. And this says 1.5 interest per month. This doesn't say compounded monthly. This already gives you the I. So the wording, right? So 1.5 is 1.5%, and then you convert that to a decimal, dividing by 100%, okay? So everything's already there. You just have to use the right formula. So your payment is your present value, and then I on top, and then 1 minus 1 plus I to the minus n. So let's plug everything in. I don't know my payment. Your present value is, the TV was $1,400. Your I is, oh wait, too many zeros there. And then you have 18 equal payments. So you want to key all of this in, and let's see what we get here, okay? So we have 1,400, and then we have that fraction. So your monthly payment, you probably guessed, is going to be rather small, $89.32. Okay. And this wants to know, so how much are the monthly payments? How much interest do you pay? Remember, so that is, what's the money, right? So the TV cost this much, right? And then total paid over the 18 months, right? So that would be each payment times how many payments did I make? 18. So altogether I paid. So we see what's the difference in these two. $207.76. This is the interest. Right? So that's the thing though. So however much the TV was, okay, I take out a loan for $1,400, right? And what some people do is they will like pay it off and then put it in another account that has a lower percent. If you want to do that, you see, you pay $207 in interest here, right? And what some people will do is, I know some places will have like a layaway or something where you don't even accrue interest. You can make some payments and pay it off that way. So just calculate the total amount of money you've paid, right? And then what's the difference between, the TV and the total amount of money, and that would be your interest that you accrue. So this is not interest, remember, that you're getting. This is interest the place that set you up with this loan is getting. So they're making money off of that. Okay. So this one talks about amortization schedule. We're not going to do one of those. Okay. As you see, this is kind of a setup here. Okay. That let's say you have $1,000 at the beginning and you want to pay it off in 6 payments. So that calculates your payment should be 172, and then some of it is interest as well, right? So how do we get this interest, right? So typically the interest is off of the unpaid balance. You'll see that's around 10% here, because I think this one is, not 10, 1%, okay? So 1% of 1,000 is 10, so that's the interest. So we're going to add that 10 on and then take away the monthly payment, and now we arrive at this unpaid balance reduction, because it's a difference in the two. And then if you subtract those two, right? So you always pay your interest off first. That's always what happens. Whenever you make any sort of loan, you're never paying the principal. You're always paying what interest is accrued first, and then the principal next. So that's how you can read this table. Okay, and this keep happening every payment period. So this is useful if you want to compute your own. Some people really like this sort of thing. Okay. So equity on a home. Okay. So let's say you bought a home 8 years ago for $100,000 and financed the home paying 20% down and signing a 15-year mortgage at 5.5 on the unpaid balance. The net market value of your home is now $135,000, and the family wants to sell the house. How much equity does the family have after making 96 monthly payments? So this sort of question, some of you might have a house, and after this, if you're curious, there is a automobile one, and there is one with a credit card, okay? It talks about other stuff. So we'll do these few word problems here. So if you pay 20% down, right? That means, so I have 100,000. I take away 20% of that, 100,000. So now I'm at 80,000. Okay. And then my mortgage is 9%. Oh, sorry, not 9, 5% of the unpaid balance. Okay. So 8 years, so that's your T. So one thing you want to note here is it does talk about quote unquote monthly payments. So from that, you can derive that your M would be 12. Your R we know is up here. So then your I would be the difference between, not the difference, the division between those two, okay? So if we just divide those two, Right? We get around 0.00458. Right? We know that this is currently the present value, how much you're taking the loan out to be. Okay. And then since we have monthly, how many years? 8 years, right? So 8 times 12 is, let's make sure. Oh, sorry, it says 15 year. I left that part out. So it's not 8 times 12. That is my mistake. It is 15 times 12. Right? So if we do 15 times 12, what do we get? We get 180. So that would be your in here, would be 180. So let's key everything in. So we have, what would our monthly mortgage payment be? So we have our present value there. And then we put our interest rate on top. And then raise to the minus 180. So let's see what our payment would be. So we have 80,000 times and then 1 minus so your monthly payment is $653.49, I'll say 50 cents. Right. Right. So let's say that, okay, I'm paying this for, quote unquote, how many years, right? So it says I'm paying this for 8 years, right? 8 years have passed. So I'm going to use this payment and do that for 8 years. Okay. And then how much, right? What would be the present value, right? So I'm kind of computing that now. So the present value would be 653.50. And 1 minus 1 plus my same rate. Makes that a little more legible. So you want to think this is for 8 years, so your in will be different. So when it's 8 times 12, which would be 96. Right? So if I compute this, let's see, what would I get? So your present value currently is right. So we're just going to say it's 50,600. Okay. So it says here that we have what? So you want to think, how do I compute equity in the home, right? So you can think equity in your house is the market value. This is the current market value minus the unpaid loan balance. So in this sort of problem, the current market value, it says it's this. And then it says how much equity does the family have after making those 96. So we did the 96 here, right? So what's the present value? So it's this, right? So if we subtract these two, that would be our equity. So 84,330.86. Okay, so that is the equity for. Okay. So think of it like this. This right here, the second part, because I know some of this might seem a little weird, so let's just walk through the problem again. So what we're doing is the first part is we're finding the monthly payment. So if you want to take a loan out for $80,000, right, to pay off a house, right, and you want to do it over the course of 15 years, the monthly payment has to be $653.50. Okay. So once we get that, we use the present value formula again here when, let's say, if I make those payments, how much is going to be there? What's the present value? Okay. So then that would be the unpaid balance, right? Because that's the current present value of the loan. Okay. So you want to think, if you sell your house, what do you have to take away first? You have to take away what you owe, right? And that would be your equity, or how much you would technically get. You can think of equity as, if you sold your house now, you still have this loan, how much would you make? Like, what would your profit be in essence, right? And they use the term equity for that you can take away all this money, okay? So think present value, you can think of it as currently what would be the value of the loan, okay? So all of these kind of are intertwined together, okay? All right, so let's think about this a little more, read through the problem again. Okay. And I do think so. One thing I want to comment on, there isn't one like this in your homework, but I do think I have a slight error. So one thing to note is that, and it'll be slightly here, that I should have wrote this 96 should actually be 84. That's my mistake. So you can think of it as, if I want to, let's say you take out a loan for 15 years. And if you've already paid on it for 8 years, okay, how many years are left? There would be 7, right? So then this number here is 7 times 12. So this is, remember, what you paid off left. That's my mistake. I do apologize. So let's just do a really simple calculation here and fix this. So this should actually be that this is how much is left on the loan. So if this was 16 years, then what we did would be great because it's the even part, but this is not. So just think, if I want to sell it at 8 years after I get the loan, so 8 years in 15-year loan means 7 years are left. So then 7 times the 12 would give you the 84. And that's the number that needs to go there. So I do apologize for that, but we're fixing it right now. And then we would just subtract it here. So I had the wrong number wrote down. And so let's see how much we would actually make from selling this house. So 45482 point. So 89517.44. So I don't recall any question like this being on your homework, but there might be one embedded in one of the questions. So if you do have any confusion, just send me an email and we can always talk about it. So automobile financing. So you negotiated a price of $25,000 for a new Bison pickup truck. You have a choice of 0% financing for 48 months or $3,000 rebate. If you choose the rebate, you can get a loan from a credit union. Which option is the best? Okay. So let's say if you do 0% financing, then, so with 0%, this means that you're going to take how much the car is worth divided by how many months, and that would be your payment. So $525. That's your payment. But if you want to do the rebate, right? So the rebate will be $3,000. So that means your present value with the rebate is $22,200. And then we're going to plug that in. So compounded monthly means that your I would be, right? Because it says compounded monthly. It doesn't say per month. It says compounded monthly. Your N is 48 months. Okay. So let's plug in everything here. Let's write our formula. So your payment, if you did the rebate method, would be, right? And then we have our I. So let's compute what is our I here. We divide those two. .00375 divided by 1 minus 1.00375. So just use the formula. And So remember the formula that we talked about up here. Right? What would your payment have to be? So doing all of this, we see that what happens? Our payment is $506.24. So in this problem, the rebate is the best, right? Because you're paying the least amount of money per month. Because you're going to save, around $18 every month. Okay. So credit cards, annual interest rate on a credit card is 19% compounded monthly. How long will it take you to pay off an unpaid balance if no new purchases are made and the minimum payment of $30 per month is made each month? Okay. So that means, hypothetically, you might have some family members that have done this where, like, my mom, for instance, she would take out credit cards and make the minimum payment, and it would take you a very, very long time to pay it off. So let's see how long it would take. Okay. So there is a quick and easily formula for this. So you can see this in the book, right? So I won't go through all the derivation because I know sometimes it can be kind of confusing. But you have this formula, right? Present value equals payment. And this is on page 164. And then 1 minus 1 plus I to the minus n over I. So they go through some derivation of how to solve for n here. So solve for n, you can check the book. So the book gets that n equals minus natural log of 1 minus I times present value divided by your payment, right? Close parentheses, all divided by natural log of 1 plus I. So in this problem, we will just plug in things. Right? So in this problem, your rate is 0.1899, your M is 12, so your I would be what that there is. Your unpaid balance, that's your present value, is how much is on your credit card. And your payment, unfortunately, is you want to do the minimum, and you're not making any new purchases, right? So let's figure out what I would be. I would be .015825, okay? So we need to compute this. So I'm going to use Desmos. Okay. So let me just take a photo of this real quick so I don't lose any information. Okay. So let's go to Desmos and see if we can get the appropriate values. Right, so you want to do your minus first, and then do your divided by. We have that fraction. The top part was natural log. So how do I get natural log? So functions, scroll down to natural log here and type in that. Okay? And then do 1 minus your I, which we got to be 0.015825. And then parentheses, present value divided by payment. So your present value is what's owed on the card. Oops. Divided by payment, $30. And then go to the right, close that, close the other parentheses there, and then on your denominator, go to functions again, do natural log, and then we're going to do 1 plus 0.15825. Don't forget there's a special 0 here. I need to make sure I include that. So it says it's going to take 157 months. So we're going to round it off because we would have some left. So this will take you over 10 years to pay off at the minimum. Okay? So this is ridiculous. Okay, I'm sorry, but so never pay off the minimum. Okay, I mean, if you want to do that, fine, but you'll see how long this is taking, right? So we get 157.37. So 158 months. So I hope you enjoyed the video. Well, I won't talk about anything else. I mean, they have this nice problem solving here if you want to look through that. There's a nice table. But email me if you do have any questions. Thanks again. And work hard on your Unit 3 project.